welcome to new session of the course of differential equation. In this session we will discuss about the non-homogeneous differential equation. See, we can consider a linear differential equation, linear non-homogeneous differential equation as L of y is equal to y double dash plus p of x y dash plus q of x y is equal to g of x. Here we have functions p of x and q of x and g of x are the functions in x alone. These three are the functions in x alone. See, this is a non-homogeneous differential equation. See, we already discussed about the solutions of the homogeneous linear differential equation, and our task is to how to solve the non-homogeneous linear differential equation that we will discuss in the upcoming sessions. See, dear students, here we have the corresponding homogeneous equation as y double dash plus p of x y dash plus q of x y is equal to 0 is the corresponding homogeneous linear differential equation. And we can solve this differential equation that we discussed in our previous sessions. And based on that we can solve this one, and while solving this we will get see, while solving this we will get y is equal to c1 y1 plus c2 y2, sorry, c1 y1 plus c2 y2. See, here we have, this is the general solution that we discussed. This is the general solution of homogeneous linear differential equation, that is equation number 2 that here we mentioned, that is. See, here we have y1 and y2, and y1 and y2 are the fundamental set of solution that we already discussed. This is the fundamental set of solution, fundamental set of solutions, or simply we can say that is the basis. Simply we can say that is the basis. Okay, see, my dear students, that we already discussed. And see, maybe in equation 1, come back to equation 1, here we have equation 1 is here, and the equation 1 is actually maybe it may have the solutions y1 and y2 are the solutions of these equations. I would like to say this is equal to, let y1 and y2, capital Y1 and y2 are solutions of non-homogeneous equation, are solution of non-homogeneous equation 1. This is our non-homogeneous equation, that is actually y double dash plus p of x y dash plus q of x y is equal to g of x. This is our equation 1, that is the non-homogeneous linear differential equation. See, if these two are the solutions of the non-homogeneous equation 1, then their difference is the solutions of the homogeneous equation, that is, then their difference y1 minus y2 is a solution of homogeneous linear differential equation, solution of homogeneous linear differential equation y double dash plus p of x y dash plus q of x y is equal to 0. See, dear students, this can be considered as one of the theorem. See, y1 and y2 are two solutions of the non-homogeneous linear differential equation y double dash plus p of x y dash plus q of x y is equal to g of x, and then their difference y1 y2 is a solution of the homogeneous linear differential equation y double dash plus p of x y dash, the corresponding homogeneous linear differential equation, that is y double dash plus p of x y dash plus q of x y is equal to 0. That is maybe that is y is equal to y1 y2 will be equal to, sorry, y1 minus y2 is actually equal to c1 y1 of x plus c2 y2 of x. Here y1 and y2 are the fundamental set, y1 y2 are the fundamental set or the basis, fundamental set of solution, fundamental, sorry, are the fundamental set of solutions or basis of the homogeneous linear differential equation. So, my dear students, our thought is that how can we solve a linear non-homogeneous differential equation? See, just we discussed about the just an introduction of the non-homogeneous equation. Consider a non-homogeneous linear differential equation is here. Our thought is that there is corresponding, we can find the corresponding homogeneous part. As we discussed before, we understood that may have a general solution, that is C1 y1 plus C2 y2, where y1 and y2 will form a basis for that solutions. Okay. And based on that, we can say that for corresponding to every non-homogeneous linear differential equation, there will be a corresponding homogeneous equation is there. This is the homogeneous equation corresponding to this non-homogeneous linear differential equation. So, that what we can say that we can write the corresponding homogeneous equation that may have a general solution C1 y1 plus C2 y2, and we can say that there will be a solution for the non-homogeneous equation. The solution, the general solution for non-homogeneous linear differential equation is actually, we can say that is y is equal to C1 y1 plus C2 y2 plus, sorry, C1 y1 plus C2 y2 plus another one is the yp of x. Here we have a new person is here, that is yp, or simply we can say that this is equal to y is equal to yh plus yp, where yh is actually C1 y1 plus C2 y2, that is the complementary function. This is what is called the complementary function. This is what is called the complementary. This is what is called the complementary function. So, this complementary function is the solution of the corresponding homogeneous part. And see, here we have yp of x, and this yp of x is actually the particular solution, is a particular solution of this non-homogeneous differential equation. See, dear students, our thought is to how to find this particular solution. There we have two methods to find this particular solution. The first one is method of the undetermined coefficients. We can solve this by using any of this method, that is first one is actually the method of the undetermined coefficients. The first one is method of undetermined coefficients, method of undetermined coefficients is the method of undetermined coefficients. The second one is the method of variation of parameters, method of variation of parameters, method of variation of parameters. We will use any of these two methods to solve non-homogeneous differential equation. See, we can move to the first method. We will discuss about the first method here, method of undetermined coefficients. See, dear students, we can move to the next as the method of how to solve the non-homogeneous equation by using method of undetermined coefficients. Method of undetermined coefficients. Method of undetermined coefficient. See, my dear students, we know that about the differential equation with the constant coefficients as ay double dash plus by dash plus cy is equal to r of x is there. Ay double dash plus by dash plus cy is equal to r of x. See, I would like to consider this as the equation number 3. Is the third equation is the non-homogeneous linear differential equation with the constant coefficients. See, my dear students, our thought is that how to solve this is. We have many methods. We have the corresponding homogeneous differential equation as ay double dash plus by dash plus cy is equal to 0 is the corresponding homogeneous equation. This corresponding homogeneous equation may have a general solution of the form C. This have the general, therefore, the general solution of general solution of the homogeneous part equation number 4 is actually y is equal to C1 y1 plus C2 y2. But actually the general solution of equation 3, that is the non-homogeneous part, is actually that we discussed before. It is actually that is yh plus yp. See, dear students, but general solution of equation 3, the non-homogeneous part is actually y is equal to yh plus yp, where yh is actually the complementary function, that is the solution of the corresponding homogeneous equation. So, this is the corresponding homogeneous equation. So, I would like to say this is yh, this is yh, this is yh. So, we found yh, but actually we need to determine yp, So, we have a method of by using method of undetermined coefficients, we can find the yp, the particular solution. So, I would like to draw a table of yp for the corresponding value of the r of x. Here r of x is a hero, that creates the non-homogeneous linear differential equation. So, I would like to say there are choices for r of x, maybe see based on the choice of r of x, to find particular solution yp, we use this table. See, dear students, I would like to draw this table for this is the choice of this one r of x, choice of the non-homogeneous part r of x, See, my dear students, based on the choice of r of x. Okay. Then the complementary function yp, that is the choice of particular solution, choice of yp. Fine. Suppose if the r of x, we know that the differential equation may be ay double dash plus by dash plus cy is equal to r of x. Okay. Consider if r of x may be the exponential function. Suppose r of x is of the form k e raised to px. If the r of x is of the form k e raised to px. Okay. If r of x is k e raised to px, see what will happen, then definitely this one is yp is c e raised to px. C e raised to px. C e raised to px. Okay. So, we will apply, instead of we can find yp and yp double dash and yp dash also we can find. we can find if yp is equal to c raised to px, we can find yp dash, yp double dash, and we can apply here in this equation 3, and by applying equation 3 we can find the actual value of c. And after finding that, we can replace here yh is we can find the yh, and after finding the yh we can apply yp is here. So, we will have the solution of the non-homogeneous differential equation. See, dear students, maybe they have other choices, maybe this one r of x may be the polynomial, the nth degree polynomial. So, if this is equal to, suppose that is equal to p n of x. P n of x is general solution of the nth degree polynomial, where n is equal to 0, 1, 2, 3, where n is equal to 0, 1, 2, 3, etc. Okay, 0, 1, 2, 3, etc. See, if p n of x is a polynomial, then we can write this is as a corresponding choice of the y of x as k n x raised to n plus k n minus 1 x raised to n minus 1 plus etc. plus finally, we will have k 1 x plus k naught. Okay. We can apply instead of r of x, we can apply, if r of x is a nth degree polynomial, instead of yp, we can apply yp as the nth degree polynomial this, and we can find the yp dash and yp double dash, and can apply in 3. Apply after applying the 3, we can find the value of the k 1, k 2, etc., k naught, etc., k n minus 1, k n, and can replace all these values here. We will have the we will get the yp, and after getting yp, see dear students, we will have yh is there, and while just paste and apply the yp here in this equation, we will get the general solution of the non-homogeneous differential equation. Okay. I would like to invite your attention, students, to the next question. See an example. Solve the non-homogeneous differential equation y double dash minus 4y dash plus 3y is equal to 10 e raised to minus 2x, 10 e raised to minus 2x. See, dear students, here we have the non-homogeneous equation, that is linear non-homogeneous equation with the constant coefficients. So, the corresponding, as part of the solution, we can write the corresponding homogeneous equation, corresponding homogeneous equation. See, which one is corresponding homogeneous? We just remove r of x from here, minus 4y double dash plus 3y is equal to 0. I would like to consider this as equation 1 for here, and this is 2. See, here we have the value of r of x as 10 e raised to minus 2x. Okay, fine. And here we have the corresponding homogeneous equation is here. We know this is actually the second order linear differential equation with the constant coefficients. So, we can to solve this we will find the auxiliary equation. We have the auxiliary equation is see, what about the auxiliary equation? Y double dash lambda square minus, or simply what we used here, it is actually m, maybe instead of lambda, we in our previous lectures we used the term as m, therefore, m square minus 4m plus 3 equal to 0. See, dear students, have to find two values, their product is equal to plus 3 and their sum is equal to minus 4. I would like to consider two values, that is equal to minus 1 into minus 3 equal to plus 3, and this is minus 1 plus minus 3 is equal to minus 4. Okay, fine. Therefore, we can write this as m square minus 1 into sorry m minus 1 into m minus 1, this is equal to m minus 1 into m minus 3 equal to 0. Okay, fine, we can find the value of m is equal to 1 and m is equal to 3. So, we got the value of m, therefore, m is equal to 1 or m is equal to 3. Fine, the roots of the auxiliary equations are real and distinct. The roots of the auxiliary equation are real and distinct. Therefore, we are happy we will get the general solution, that is the complementary function. The general solution of homogeneous equation YH is equal to, that is equal to C1 e raised to m1 of x, that is equal to m1 of x. This is actually first m is m1, the second m is m2. Therefore, C1 e raised to x, and the next one is actually this is equal to plus C2 e raised to 3x. So, this is our complementary function that we found. Now, we have to find our YH. So, sorry, YP. To find YP, to find YP. So, we have to find YP, we have to go back to our equation. See, go back to the value of r of x. R of x is actually 10 e raised to minus 2x. See, my dear students, we have r of x is equal to, 10 e raised to minus 2x. 10 e raised to minus 2x. Okay, fine, r of x is equal to 10 e raised to minus 2x. Dear students, r of x is actually 10 e raised to minus 2x. Fine, come back to our table. In our table, this is actually instead of k we have 10 e raised to px is there. Instead of p here we have minus 2x. So, we can say that this is equal to some c e raised to px. So, we can put, therefore, yp is equal to, therefore, yp is equal to c, instead of 10 k we have 10. So, c e raised to minus 2x. So, we have to find the value of c. See, dear students, to find the value of c, we just find the yp dash and yp double dash, and then we will apply to equation 1. Fine. Therefore, the yp dash is equal to c e raised to minus 2x, that is minus 2 c e raised to minus 2x. E raised to minus 2x is e raised to minus 2x into minus 2. Therefore, that minus 2 is here. And finally, we will have yp double dash, this is equal to minus 2 into minus 2, that is equal to 4 e raised to c e raised to minus 2x. Put in 1, put in equation 1, see, come back, we will have equation 1 as y double dash minus 4y dash plus 3y, y double dash minus 4y dash plus 3y is equal to 10 e raised to minus 2x is our equation number 1. Okay, fine, dear students. Also, we will have yp double dash. So, yp double dash is equal to 4c e raised to minus 2x, and then minus 4 into y dash is actually yp dash is actually minus 2 e raised to minus 2c e raised to minus 2x. So, we can say that this is equal to minus 4 into 2, minus 4 into minus 2, that is equal to plus 8 yp double dash c e raised to minus 2x is there, and finally, we will have 3 y is yp is c e raised to minus 2x. Therefore, we will have 3 plus 3 c e raised to minus 2x, and finally, in the opposite side we will have 10 e raised to minus 2x is there. So, dear students, we will have this is equal to 4c plus 8c plus 3, okay, 4c plus 8c plus 3. that is equal to this is equal to 4c plus 8c plus 3c into e raised to minus 2x is equal to 10 e raised to minus 2x. Okay. In both sides we will have this one e raised to minus 2x is there. So, we can cancel e raised to minus 2x and we have 4c plus 8c 12c, 12c plus 3c 15c. So, we will have 15c, finally, we will have 15c, 15c is equal to 10. Therefore, c is equal to 10 divided by 15, that is equal to, we can cancel by 5, therefore, 2 by 3 is there. Therefore, c is equal to 2 by 3, c is equal to 2 by 3. Find c is equal to 2 by 3. So, therefore, yp is actually, therefore, yp is equal to c e raised to minus 2x. So, that is minus 2 by 3 e raised to minus 2x is there. This is actually our yp. This is actually our yp. Okay. See, come back, we have yp is actually c e raised to minus 2x. So, therefore, the general solution of the given non-homogeneous equation, therefore, the general solution of the general solution of the given, therefore, general solution of given non-homogeneous differential equation, given non-homogeneous differential equation y double dash minus 4y dash plus 3y is equal to 10 e raised to minus 2x is actually y is equal to yh plus yp. We already found about the yhc, dear students. Come back, you have yh is c1 e raised to x plus c2 e raised to 3x. Okay. Therefore, this is equal to c1, therefore, y is equal to c1, yh is actually c1 e raised to x plus c2 e raised to 3x plus yp. See what about yp? Yp is actually 2 by 3 e raised to minus 2x. So, this is equal to 2 by 3 e raised to minus 2x. So, this is actually the general solution of the given non-homogeneous differential equation. See, we found by using the concept 1 of the table. This is the method of undetermined coefficient. We have many methods and this is the first method that we discussed here. Okay, dear students, can have many methods we will discuss here. We will discuss 6 methods to solve a non-homogeneous differential equation by using the method of the undetermined coefficients that we will discuss in our upcoming sessions. Thank you for watching these videos. Continue watching. Thank you very much.